Can you hear me? Okay. Hello everyone. How are you? As you know, I have received several messages about your exam, and all of you requested to skipping exam, but all the students from Iraq, other than you, in our university, I lived in Kurdistan, and I have several students from Iraq, from different states, from Diyala, from Kirkuk, from Soleimania, from Duhok, from Arbil, and so on. All of them contribute in my have contribution in my class, and they attend to our exams, our oral exams, and there is no problem. So as I informed you in parting sessions, we have a final for 6 months. And I have defined you some. We provided you several papers, and you have selected some of them to represent in our class, but I have no feedback till now. So I skipped from giving you exercises and other activities in class. So we have an exam for altogether 10 marks, and in next session, in next week, we start to see your representations about your study project, and then you could represent a practical or implementation of your study project in class for altogether. I have considered this situation. You could not resist in Iran because of COVID-19. At the beginning of the semester, I have defined 10 marks for your homeworks, for your projects, and if you have more contributed in our class, we wanted to define extra 4 marks for your homeworks. But as you know, so many of your friends absent in this class and don't have any contribution in our class. On the other hand, you can say that this matter that it may be our presentation is not so well for you, so I have supported you by other fluent representations of these materials, either by Professor Afud or by the Indian professor for later chapters. As you have seen before her lectures, I have defined to see some selected videos, so possibly you have no extra problem in talking these subjects. So I want to have an exam, oral exam. You should be online, and you should explain some of the teached concepts of this course according to our textbook, according to our slides, and I asked several questions about some samples or some exercises of your book from you, and you should reply me. It's not acceptable to skipping the exam. Okay. If you have any other problem, please tell me about your problems. Okay, no problem. So in the next week, I want you to start your presentations. I want to have some extra sessions so that all of you could can represent your homeworks. Let me go to the slides, as I have talked about it previous session. As you know, in the previous session, we have talked about some structural coverage criteria, such as node coverage, edge pair coverage, simple path coverage or prime path coverage, and other extra coverage criteria for handling loops. We have defined the terms such as side shift, detours according to our structural graphs in this slide, and the final two coverage criteria we have explained for you are these two coverage criteria: simple round-trip coverage and complete round-trip coverage. And in this session, I'll talk about the data flow criteria. As you know, we can augment our control flow graphs by the data flow in our programs. There are some concepts that I will define in this session about data flow and how they could be used as coverage criteria, and how they could be used in test generation process. Initially, we have two concepts: the definition and the use. We use these two terms to define the flow of data along the program. Suppose in your program is modeled by this graph, by this initial, for example, an assignment statement such as this. So, is a location in which a variable x is defined. Okay. Then, in some nodes later, in some way, in some execute variable could be used in some extra statements, such as these statements. Okay. In node 5, at this graph, the variable x is used to compute the value of another variable z. This is the same as this as done in this node. So we say that this is a definition and this is a use statement. This is a definition statement and this is a use statement. Some other definition statements exist in our program, such as input statement. For example, in C++, we can read some variable value from standard input by cin statement. So the cin statement is an input statement which defines a variable from receives a variable for a value for a variable from keyboard. So this is a definition statement or def statement. Another type of def statement could be parameter passing for method call. In a method call, we pass some values as parameter. These values could be set in some variables in the body of the method, the call method. So this could be a definition statement or def statement. The relation, the ways that connect the def location to use locations relates the way of using any variable or shows the flow of data along the program, along the control flow graph. So in this session, we talked about how to handle this def use or this data flow as coverage criteria to generating test cases. Let me see your messages. There is no screen. Let me see. Can you give us more assignment and calculate the final exam out of 4 marks? The final exam could be 6 marks, and I will give you some assignment from previous lectures and the 2 new chapters. Okay, no problem. Let me restart my screen. Stop sharing. Excuse me. Record the meeting. Okay. Let me share it again. Okay. Can you see our screen? Oh no, okay. I don't record it, so let me redefine these two terms. As I said, in this session I'll talk about the data flow criteria. The data flow criteria is a possibility of using control flow graph to show the flow of data along the execution passes along the program by using two concepts, the definition and the use. When we store any value for a variable, we say that we defined a variable such as this statement. In this location, this statement defined x, because this, by executing this statement, the value 42 could be stored for variable x. So this is a definition location for x, and these two locations, the location 5 and location 6, are the true locations for variable x. Besides this, these locations also are a diff location for variable z. The goal of data flow that values are computed and used correctly. So we focus on the definitions and uses statements in our program. As I told you, the definitions statements could be an assignment statement, could be an input statement, or parameter passing through some method calls, and use statements is obviously trivial for you when a variable contributes in some computations for defining the value of another variable. We say that the first variable is used to define the second one. So we define this term in short def. We define this definition as a location where a value for a variable is stored into memory, and we define the use as a location where a variable's value is accessed or is used to compute to some computation from an assignment statement. Besides these two definitions, we can define the depth of any node or any edge of our data flow graph. We define the depth of node 1 as x, because all variables are defined in this location is just the variable x. There are no any definition in these nodes. So the defined variable, the only defined variable at location 1 is x. So we define the set of all of variables which is defined in location 1 as a set for depth of 1, depth of node 1. We say depth of node 1, and depth of node 1 is a set which includes just a variable x. Okay, and this is defined also for depth of location 5, depth of location 6. These two are the same, and both of them define the variable z. It's possible in some nodes we define several variables, because as we will see soon in next section of this chapter, when we try to model a program, a block of code is considered for each node. A block of code which executed together with no branching could be considered as a node or a location. So it's possible to have more than one variable for depth of one node. And the use of a node is defined as a collection of all variables which are defined at that location. For example, the use of node 5 is x, and this is same for the use of node 6. So the values given in depth should reach at least one, some, or all possible uses. This box defines the main clue to create some coverage criteria, to define some data flow criteria. So the first one, the value given in depth, for example, the value stored for x at this location, this definition should reach at least one use. When we want to test once this value, it's enough to test to execute a test pass such as this. When we want to test once this value, we should test just a use of that variable. So this test pass is enough to test one use. When we want to test more uses of this variable, it's enough to test this pass and to test this one. Okay. When we want to test all possible uses, we should define enough test passes to cover all uses of some variable, and possibly we should test all test passes that connect each definition to each use. According to three possibilities, according to three clues, we define three types of coverage criteria according to data flow along our program. So let's go ahead and see other concepts. As you saw in the previous slide, the def of n or def of h is defined by the set of variables that are defined by a node or edge. So far you have seen several control flow graphs, but none of them define an assignment and a definition statement over any edge of the control flow graph or the data flow graph. Because in our modeling we define that a block of statements in which all of them are executed together with no branching could be a node. It creates a node or a location of our program, as we will soon see in next chapter. So our definitions in this chapter are defined for nodes, not for edges. But as I said, in some modeling or some models, such as finite state machines, such as label transition systems, the definition statements are set to edge. So the def of edge in those modeling style are usable. But in this concept, we just use def of n node, not def of an edge. Okay, the def of a node is defined as the set of variables that are defined by a node. Or this is the same for def of use, because in this chapter the uses statements, all of them are located in nodes, not over edges. So the use of n is defined by the set of variables that are used by a node. And in other modeling languages, use of edge also means. What is a DU pair? Def use pair. A pair of locations such as location I and location j could be used as a DU pair if a variable v exists in which that location I defines v and location j uses it. So a pair of locations li and lj such that a variable v is defined by node I and used at node j, at location j. We say that li and lj be a DU pair. Okay. And what is a def clear path? A path from location I to location j could be can be a def clear path with respect of some variable v if v is not declared again between li and lj. If v is not given another value, is not stored again new value, when v gets no new value between li and lj. Okay, at the path which connect li to lj, we say that the path of li to lj is a def clear because there is no new assignment for variable v between li to lj from corresponding path. We define the term reach. We say that location Li reached the location Lj with respect to variable v if there is a path that connects Li to Lj and there is no another definition for v at that path. If there is a depth clear path from Li to Lj with respect to v, variable v, the depth of v at Li, we say that it reaches the use of Lj. For example, in this graph, this definition reaches this use, and also we say that this definition reaches this use again, because there is this is a depth clear path. If we have defined x at this position or at this position again, so this path could not be a depth clear path because x is already defined at some of these points. But in this graph there is no new value for x between node 1 and node 6 according to this path. So this is a depth clear path from L1 to L6. Okay, so we say that this definition reaches this use of x. Also, this definition reaches this use via this path, via this depth clear path. This is a depth clear path. Okay. A DU path is a simple subpath that is depth clear for a variable v from depth of v to use of v. As I said before, this is a DU path. This is a DU path, diff use path, and this is another DU path for this use. Okay, and this notation defines the set of all DU passes from node I to node J with respect to variable v. For example, in this graph, there are two DU passes from node 1 to node 5 according to a variable x. There are two. This is one DU pass and this is another DU pass. And also we have two DU pass for this use. This is one DU pass and this is another DU pass. So for each of these nodes, DU 1 to 5 according to variable x includes a set of two DU passes. And this is the same for node 1 and node 6 and variable x according to our example. Okay, and this notation defines the DU passes, the set of all DU passes that starts from node I to any uses of this variable at any other locations. So this defines the set of DU passes that start from NI. For example, in previous graph, we have 4 DU passes which start from node 1. In this graph, we have 4 DU passes, is 2 DU pass for DCUs and 2 for DCUs. So we have 4 DU passes which started from location 1. So keep your mind these definitions. We have several definitions in this slide, and we will use them in later slides. The def of n defines the set of all definitions defined in or at node n. The use of n defines all uses of all variable used variables in node n. The DU pair defines a patient event and location J. A dead clear path from J in which there is no new definition for variable v along the paths that connect Li to Lj, and we define the reach if there is a dead clear path from Li to Lj according to variable v, and I defined DU paths, the set of DU pairs from Ni to Nj according to variable v, and all passes or all uses that started from this, all DU passes that started from location I according to some variable v. Okay, no problem. And how about the Turing in this? Turing of control flow environments as Turing loops in chips in previous lecture, and in this lecture Turing concept for DU passes, how we could tour each DU pass. We should define in order to design some test cases. We should define some test passes that cover our DU passes, because in this context, we define our test requirement as DU pairs or as DU passes or as cover definitions, and so on. So you should define the concept of Turing a DU pass. A test pass P can tours a DU pass, which the DU pass is a subpass of D with respect to variable v if P tours D and the subpass taken is depth clear. For example, in this graph, this is a tour, this is a test pass, because it starts from initial state and ends from a final state. This pass towards this DU pass, and this pass toward this a test path should started from one initial node and finished at a final. So this is not a test. This is by this test path. Okay. The formal definition of this is provided here. The site trip is also could be defined in data flow graph. It can be used just as with previous Turing definition as we saw in structural coverage criteria. Three criteria could be defined to a flow concepts. Use four, 5, 7. Because these test paths cover a use for this definition. One use. Per each definition, it's enough to cover a use. Okay. This could be and another coverage criteria could be defined as this expression: get to means that causes for each definition. Cover all uses. Cover all uses. For example, in this control flow graph, 2 test passes are needed to cover all uses. We have 2 uses for variable x. So there are 2 passes, each of them cover one usage of x, one uses of x. Okay, this is a test pass that covers the test pass cover use of x. Another coverage criteria be, as you see, following due passes defines 4 escape: 2 for this diffuse and 2 for this diffuse. All DU passes between location 1 and location 6 are 2. This one and this one. And all DU passes for location 1 and location 5 are 2 again. This one and this one. So we need several test passes. At least we need 4 test passes to cover all DU passes. Okay. According to these 3 notions, we could define 3 coverage criteria in data flow context. The first coverage criteria cover all depths. Make sure every depth reaches a use. Per a definition, we should reach a use. So for each set of DU passes is test requirements contains at least 1 pass D in it. It's enough to choose 1 pass from a definition to a use. It's enough to have to check 1 use of each definition. As you can remember, the DU N and V defines all DU passes that started from N. So one of them could be included in our test requirement for this coverage criteria. Okay. I told you according to our example, 1 test pass is so 2 test cases to cover our control flow graph, our data flow graph according to this coverage criteria. All uses should be checked for each variable, for each definition. In this control flow graph or data flow graph, there are 2 uses. When we say all uses should be covered, these 2 uses should be covered. These 2 uses should be covered by could be covered by 2 test passes. One such as this one, another one is okay. All uses. The first one, all depth coverage. All depth coverage means per definition, you should experience a usage location, a used location. This is enough. For all uses, we should define several test passes that experience all uses of our variable. And the last one, all DU pass. All DU pass, as I told, we have 4 DU pass in this graph. So the last one is all DU passes. For our example, all depth coverage defines just 1 test case, just 1 test pass. All uses coverage defines 2 test passes because there are 2 different test requirements. And all DU passes defines 4 test passes because there are 4 different DU passes in our test requirements. Okay. This is summarized at this slide. All of our talking is summarized at this slide. For example, when we want to cover all depths, there are just 1 depth. And to cover this definition, it's enough to cover 1 uses of them. For example, the pass 1, 2, 4, 5, 1, 2, 4, 5 cover this definition. To cover a definition, it's enough to cover one of its uses. Okay. All uses, there are two uses, and so we should have two DU passes. So our test requirements for this coverage criteria are two. 1, 2, 4, 5. 1, 2, 4, 6 is that. Okay. And all DU passes for this example, as I told you, are 4, because there are two uses, and per each use we have two DU pass. We have two DU pass. Okay, so there are 4 DU passes. For example, in your exam, I present you a control flow graph, a data flow graph, and I asked you to define the test requirements for all users coverage, or all DU passes coverage. You should define all DU passes test requirement. You should define the test requirements for this coverage criteria according to the presented control graph. So I suggest that you look at the final exercises at your book. Okay, for your exam. And what about this subsume several coverage criteria located at this zone of this graph, and in this session we define 3 extra data flow coverage criteria. As you know, the node coverage means cover all nodes of a control flow graph, and the edge coverage means covering all edges of a control flow graph. Excuse me. Assume node coverage, because covering all edges guarantee that we can visit all nodes in connected graph in connected graph covering all edges. For example, a path of list covered in edge pair coverage. So edge pair coverage subsumes edge pair, and you have seen this in previous lecture. And a prime path coverage is defined to handle how the I have explained you in previous. Tell me why. But has self loop. When we have a self loop by some H pairs which is not prime pass. And see now. Okay, let me at this slide you have seen that there are H pairs such as this one and this pass, because in prime pass we have no repeated node in our pass except the first one and the last one. These two H pairs could not be defined as prime passes, so prime pass could not subsume H pair coverage. Prime pass coverage could not subsume H pair coverage. We have defined this subject in previous lecture. So the prime pass coverage just subsumes complete round trip coverage. We have defined round trip coverage for deal with loops. In complete round trip coverage, we should cover all passes which could be defined in a loop and started by one node and ended at the same node. We have defined the complete round trip coverage and simple round trip coverage. The complete round trip coverage subsumes simple round trip coverage, and all of these coverage criteria are subsumed by complete pass coverage. And I told you that complete pass coverage is impossible in presence of loops. If we have any loop in our program, we have an infinity passes. We could define infinity passes for our program. So complete pass coverage is not possible. And on the other hand, we defined this in this session data flow coverage criteria. We defined 3 data flow criteria: all def coverage, all users coverage, and all DU passes coverage. And it's obviously that all def coverage is subsumed by all users coverage. All users coverage subsumes all def coverage, and all DU passes subsumes it's to their definitions. Okay. And the last 2 points, according to this summarized option edges located in a loop, as you see in side tree. Okay, but why all users coverage subsumes H. In our control flow graph, all pass is not in our graph. Or the definition is not necessary for programs a lot. You define a variable, but it's never used at all in your program. So a definition is not important for in your program, and covering them is not matter at all. So we finished section 1 and section 2 of please ask your questions if you have any question. If you have no question, let me start the next section of chapter 7. The section 7.3. Thanks a lot. Just type your question. Okay, I will define some homework for you, but as I told, the exam you should take an exam for about 10 marks, about 6 marks. Okay. If you have noted to my talking, I informed you a simple question. For example, I told I provide you a control flow graph and asked you to define the test requirements for example, all DU passes coverage criteria, or for example the prime pass coverage criteria, or for example the H pair coverage criteria. So for each of these coverage criteria in chapter 7 you should define all test requirements according to each coverage criteria. And let's go to section 3 of this chapter to see how to deal with source code according to this taught coverage criteria. In this section we will talk about how to extract control flow graph or data flow graph from a source code. A common application of graph criteria is to program source. So how it could be possible? It's possible to extract a control flow graph or data flow graph from a source code. Is the subject is the main concerns of this this part of chapter 7. Graphs for source code are usually defined as control flow graph, but some information such as where data are defined or data is used in a program could be augmented to control flow graph and use it as data flow graph. So usually we extract control flow graph to show the ways of execution of any program and define the definition of node coverage according to a source code could be as this statement: execute every statement, obviously cover all nodes of our control flow graph, and execute every branch, guaranteed the coverage of all edges of a control flow graph. You have seen that loops could be defined by extra nodes in control flow graph, such as nodes to check a condition or nodes to increment our counter on our loop counter. So looping structures such as for or while loops could be defined by graphs, and we will see in next slides how to define loops according to the source code. The data flow coverage could be augmented to control flow graph by, as you see in previous section, by defining the definition statements such as assignments, such as input statement, or method calls for definitions and its uses. Defs are statements that assign value to variables. I told you before about this. Uses are a statement that uses variable. It's okay for you. A control flow graph models all executions of a method by describing control structures. Nodes defines statements or sequences of statements as a basic block which could be executed altogether with no any branch in them. Sequence of a simple statement of assignment of not branching, not method calls, okay, could be a node. It transfers the control of execution. Let me to go a simple example and see how to model a piece of code as a control flow graph. As you know, we start from an initial location for this piece of code. From an initial location, we should define a branch. So the first node have a branch that checks the relation of x and y. If x is less than y, this piece of code executed, and else this statement could be executed. Okay, so in the control flow of this piece of code have a branch such as this. We start from an initial location, and at this initial location the relation of x and y should be checked. If x is less than x be less than y, then this piece of code should be executed at location 2. This sequence of statements which could be executed together could be defined at this location. Okay, and else otherwise, when x is bigger than, when x be bigger than or equal to y, this statement should be executed. So in location 3 we just have one statement instead of a block of statements. This is a basic block, basic block of two statements, and this basic block just have one statement. Okay, and finally, after execution of this if structure, the program terminated according to this piece of code. So from location 2 and 3 we can move on to the final location with no condition expression. Okay, just after the execution of its statement, the control can move on to the final location. Okay, and for this structure, this is a simple structure. This is simpler than the first one. We could simply define a control flow graph by an initial node labeled by, for example, 1, and defines a branch. If the condition of branch is true, this basic block should be executed, else we go to a final node such as this. If x be less than y, the if block should be executed. If x be less than y, this basic block defines location 2, and else otherwise we move on, we go ahead to the final state, final location. Okay, let's go to see some extra simple structures to see how we can define, how we can extract control flow graph from any piece of code. For example, in this code, again we can start from an initial node such as this and check these statements, these two statements define a new location as a final location, because we see the return statement at this basic block. Okay, and it's important that to note that there is no any edge from node 2 to node 3, because the node 2 is a final node and node 3 distinctly is final again. We define loops with probably extra nodes to be added to our control flow graph, because there is a node to define, for example, the condition checking of, for example, for loop or while loop, and there needs to define some nodes to increment the counter of loop or to initialize the counter of our loop. So we need usually extra nodes to define loops. And let me see a simple example. For example, in this piece of code, at the first statement, for a first location, we should execute this statement. So the first statement includes this first statement, this definition. Okay, and then we compare x by y as the condition of this loop. Okay, so this comparison could not be done at this location, because this statement is, if this is defined at this location, we also reset the value of x. It's wrong. So we should define a new location to compare these values. This is extra new node to compare with y. P less than y, we go ahead to execute these two statements at this new location. We define new location for this basic block for these statements, and then come back to this decision making. Okay, and this define our loop until x be greater than or equal y. When x be greater than y, we go to another location which execute this return statement. Okay, and for this loop, this for loop, this is a for loop statement. We define this for loop statement as a control flow graph such as this. Excuse me. We start from a node labeled, for example, by the value 2, and compare the relation of x and y. If x be less than y, we go into the loop and execute this statement, and after this execution our counter should be incremented, so we have to define another node to this increment statement, and then come back to the comparison statement of the loop. And you know our counter is x in this code, and it should be initialized before going into the loop. So we need a new node at this location to initialize the counter and then go to this location. So these nodes these nodes implicitly initialize and increment the counter of our loop. So to model this loop, we should use 2 more nodes as needed ordinary. Let me see your messages. Persian message, but it can't be read. Please retype your message, Ms. Tara. Let me see the time. I think it's enough for today. خانم تارا، شما میتونید از میکروفونتون استفاده بکنید. If you can speak in Persian or English, you can use mic. You can use your mic. I don't got your message. You can type your message via or type by English character, Finglish. Okay. Please ask your questions if you have any question. Okay. Your mic is enabled. I have enabled your mic. Okay. Please prepare your study project for next week. I will set a time for you to present your works, and I will define some homework and some exercises to do for previous chapters, so that you have a good mark. I'll define some homework for you, but I'll take an exam. I will take an exam. You could have an oral exam you can use your mic and discuss about some concepts of this course. Yes, let me see your let me load your book and talk about some exercises. For this session, please look at the data flow graph. Video. See for chapter 7, you should see this part, basic graphs as used in testing, and structural graph criteria. This part and this part are important for you, and then go to the data flow graph. You can see the data flow graph, and then continue to the next part. Let me this is your text, and exercise 5 is for you. So for methods, and present each case, and please do the exercise 7 for in chapter 1. In chapter 2, I think there are no any exercises at the end of the chapter. We have just 2 exercises for chapter 2. Please see this exercise again. And in chapter 3 is about test automation, about JUnit. I have informed you a complete course video, a video course. Please watch the video course, and there are several exercises in chapter 3. At the end of this chapter, I will select some of these exercises and inform you to do for chapter 3. We skip the chapter 4 and go to the chapter 5, so there is no need to doing these exercises for chapter 3. But in chapter 5 you could have some exercises. Okay, there are just 2 exercises. Please do these 2 exercises for chapter 5. And the main homework, the main part of your homework for your exam could be defined according to input space partitioning, according to these 4 structures: input space partitioning, graph coverage criteria, and logic coverage and syntax coverage. These 4. There are several exercises for each part of these chapters. These exercises, all of these exercises are important for your exam. As you see, there are several exercises just for section 1 of chapter 6, and also for other sections there are some extra exercises. You could do these exercises and be professional to solve or example or questions in your exam. Please do all exercises of chapter 6 and chapter 7 till now, till what I teach you. Let me see your messages. Okay. When I shared the YouTube, I told you to see these parts of this video. Structural graph coverage, this part and this part is important for you. These 2 parts are important. And then there are some assignments in this part help you to doing your exercises in chapter 7. And our lecture, this lecture we talked about data flow graph. So you should see these 2 parts of data flow graph for completing the chapter 7. And testing source code according to chapter 7 is explained through these parts of video. So you should watch several parts of these videos for chapter 7. So chapter 7 is the one of the most important chapters in your exam, and it's very questioning. Oh. Okay, let me open your mic. Let me see your user. Your mic. You're logged out. I don't see your username. Where is your ID? Let me stop sharing. I don't see this user. among list of my users, my participants. Open your mic. I open my course. I don't hear enough.
We don't want an exam. We want homework.
We could have a good exam about this course. Don't worry, please. Please don't worry about your exam. For example, in our exam, we start to show your PowerPoint slide, and you explain some definitions, some concepts, and you could discuss about some exercises. It's it could be very useful for you. You should do your thesis soon, and this is a good exercise for you. This could be a good experience. I suggest that don't worry about exam. I will take an oral exam. Excuse me, go ahead.
We don't pass any exam in this course. Please, doctor, we don't want the exam.
Let's for your project for about 10 marks. Your presentation have 6 marks. Your further your study have 10 marks. We want you to do 4 marks, and our exams have just 6 marks. Please don't worry about your exam. Please don't worry. Session for simple exam to see how we did. For next session, please prepare the section 7.1 and 7.2, and I will ask some question from you to see how we take exam.
Okay.
Okay.
Doctor, you can increase the degree of homework and decrease degree of an exam.
let me to have these parts be our decision till now, but if we see it's better for you to increase the part of, for example, your presentation group, we define extra marks, more than 20 marks. For example, we define 4 extra marks for who do his homework well. Okay, please don't worry about how I will evaluate you. Please do your homework. Please do your representation, implement your papers, and discuss about them. And let me to take a simple exam. We just discuss in a friendly manner. Okay, no problem.
Okay, doctor. Thank you. Thank you.
Please. All of you be prepared.
Okay, doctor. Thank you.
Okay. Thanks a lot. Excuse me, let me see messages of your friends. Will be a oral exam. I enable your mics and provide you a slide and exercise, and you can discuss about that subject, that concept, and you just discuss about the solution of some exercise. So please do the exercises of chapter 7 part 1 and part 2 for next session, to see how we have an oral exam. Okay. I appreciate you for your oral discussion, and I apologize to refuse your request, and I want you to let me have a discussion about this subject. It could be very valuable for you. Worry about manner and evaluate your work so that help you in your marks, and I hope all of you have a good marks in this lecture. And I wish to have another course with you in next semester, if possible. Okay, so we don't worry about your exam. No, the chapter 1 and 2 not difficult. I talked about chapter 7. Please prepare chapter 7, section 1 and section 2 of chapter 7. Please prepare this chapter for next session. Let me this chapter, this lecture, chapter point 2 for the next session. And all of you should discuss about several concepts consists in these two sections, and talk about some exercise at the end of each of these parts for next session. And I hope we have a good discussion about this chapter. Okay. There is no any time. The time is over. So let me finish the this session. Good night. في أمان الله.